This is a video lesson on multiplying decimals for CAP045 students, and I kind of follow along in the pre-algebra textbook, section 5.3, which begins on page 370. So page 370, 5.3, and it's multiplying decimals. And it starts out kind of reminding you what multiplication of decimals is. It's really multiplication of fractions. And if you have something like 0.7, which is 7/10, times 0.08, which is 8/100, if you were to write it out as a fraction, it would be 7/10. You should have practiced this in the first section, recognizing the place value, 7/10, times 8/100, right? 8/100. We have two places to the right of the decimal, so we have two zeros. And if we multiply that straight across, as you learned in the fraction section, you just multiply numerator times numerator, you get 56. And denominator times denominator, you get 10 times 100, which is 1,000, right? A 1 and 3 zeros. So it's 56 thousandths. And then if you rewrote that, it would be 0.056, because that would be 56 thousandths. So that's in fractional form. So you can do that with any decimal. You can change the decimal to a fraction, use your fraction principles, and multiply the decimal. We also can just multiply them like whole numbers by ignoring the decimal. So look on page 372. If we had 2.34 times 1.2, you can just set this up as 234 times 12, and we're ignoring the decimal. Notice there's no decimals. We're going to solve it just like we would whole number multiplication. 2 times 4 is 8, 2 times 3 is 6, 2 times 2 is 4, placeholder 0, 1 times 4 is 4, 1 times 3 is 3, 1 times 2 is 2, and then I add those two products together. 8 and 0 is 8, 6 and 4 is 10, carry the 1, 1 and 4 and 3 is 8, and 2. We get 2,808, but we're not done, because we have to remember that we had 2.34 and 1.2, which is actually 2 and 34 hundredths, and 1 and 2 tenths. So what you have to do is count the number of places to the right of the decimal total there are, and there are 1, 2, 3. 2 to the right of the decimal for 2.34, and 1 to the right of the decimal for 1.2. So we take our decimal that would be on the end of 2,808, like $2,808, and we move it in to the left 3 places, because we actually have hundredths times tenths. We're going to end up with thousandths, aren't we? We need to end up with 2.808, or 2 and 808 thousandths. So that's a very popular way to multiply decimals, is to ignore the decimal, multiply them as whole numbers, go back to your original factors and count the number of places to the right of the decimal, and then move that same number of places in left to create the final product, the final answer. And so you can do that all day long, hopefully, because you've been multiplying whole numbers for quite some time. The section on 373 discusses positive and negative numbers, and those rules don't change. As a quick review, if you have a positive times a positive, your product is going to be positive. If you have a positive times a negative, your product is going to be negative. If you have a negative times a positive, your product is going to be negative. And then if you have a negative times a negative, your product is going to be negative. So the rules don't change. Just pay attention to whether the factors are positive or negative and apply those rules. Just ask yourself, am I going to have a positive product or a negative product? And then do the math as you've been doing all along. On page 374, it discusses order of operations. Again, that doesn't change. It's still GEMDOS, grouping symbols, then exponents, multiply or divide, and add or subtract. Just remember your hierarchy for that. It can get a little tedious with decimals. With exponents, you just have to remember, like if you were to have something like 3.1 to the power of 2, that just means 3 1/10 times 3 1/10. Ignore the decimal and multiply 31 times 31. You have 1 times 1, 1 times 3, placeholder, 3 times 1, 3 times 3 is 9, add the products, and then move the decimal over a couple of places, 2 places, because you have 1 place for the first factor and 1 place for the second factor in the power of 2. So the final answer is 9.61. So just be very careful. Eventually, after you do a few of these by hand, you really should just get good at putting them in your scientific calculator very, very carefully. On page 375, it discusses powers of 10. 10 to the power of 1 is 10, right? 10 to the power of 2 is 100. 10 to the power of 3 is 10 times 10 times 10 times 10, which is 1,000. I hope you're noticing a pattern. 10 to the power of 4 is 10,000, right? We get a 1 and 1 0 for 10 to the power of 1, 1 and 2 zeros for 10 to the power of 2, 1 and 3 zeros for 10 to the power of 3, 1 and 4 zeros for 10 to the power of 4. So like 10 to the 9th, that would be a 1, and how many zeros? 9 zeros. It would be a billion, okay? So they have you practice a little power of 10, so that then you know that you could multiply decimals by using powers of 10 math. Each power 10 matches a place, doesn't it? So if you had the number 1.23456 times 1,000, right? You don't really need to do all the math. You just go, oh, it's going to get bigger by 3 places because I have 3 zeros, 3 powers of 10. So I'm going to move my decimal 3 places to the right, and my final answer is 1234.567. So the rule is multiplying a decimal number by 10 to the power of anything, like 10 to the power of n, you move the decimal to the right because it's getting bigger, right? When we multiply by a power of 10, a whole power of 10, you move the decimal to the right, the number of places that of n, right? So if it was 10 to the power of 11, you would move the decimal over 11 places to the right. So that's how you multiply by the power of 10. Now, then it introduces you to the circle, because you're going to be introduced to using pi, which the common decimal equivalent of pi is 3.14. So we have a circle. This is on page 376, where you have a center O and then a radius R. That's part of the diameter. That's half the diameter of a circle. If we go all the way across our circle, we get 2 R's, which is actually combined together is our diameter. Okay? So, and then if you go all the way around a circle, that's its circumference. Circumference. Okay? It's not called perimeter on a circle because it's not a polygon. All right, so kind of an anatomy of a circle: a center, a radius. It's half the distance from across the circle. It's equal distance from the center to any point on the outside of the circle. And then 2 radiuses together going through that center of the circle become its diameter. It's how wide the circle is at its widest point. And then the circumference is all the way around the circle. And really old guy named Archimedes started studying circles hundreds of years ago and discovered that there was a relationship between the circumference and the diameter, and it's always the same. And eventually these ancient mathematicians in Egypt and Greece, discovering this relationship, discovered this constant, and they named it pi. And pi is a symbol. It's like two lines with a little tilde on top, and it's approximately equal to 3.14 as a decimal equivalent. It goes on forever into infinity and never repeats. It's an irrational number. But the relationship is that pi equals the circumference divided by the diameter. In every circle, no matter how big or small the circle is, circumference divided by diameter will always yield this number pi. So if we solve for the circumference by timesing both sides by d, we end up with a formula: circumference equals pi times diameter. So you can find the circumference of any circle by multiplying it times pi times the diameter. You can also multiply it by 2 of the radiuses times pi, because that's what a diameter is 2 radii times pi. So 2r pi is also a way to find circumference. That should hopefully make sense. You need 2 radiuses to get 2 radii to get a diameter. Then you could also use 2 times your radius to get pi, or you could just double your radius anyway to find the diameter and then multiply it times pi. Let's see, then the area of a circle, how much space it takes up, was derived from dividing the circle up into little pieces of pi. And that formula then is, my pen's starting to run out here, that formula is area equals pi times the radius to the second power. Pi r squared is a popular thing to say. Area equals pi times the radius to the second power. So you would use order of operations and do your exponents first and then multiply it times pi. You could use a button on the calculator, or you use the equivalent 3.14. So you will have some circle problems where you'll have to find the circumference, the area. You might have to find the diameter or the radius. For example, if you were given to find the circumference of a circle with a radius of 12 feet, this is example 9 on page 378. Okay, well, circumference is going to equal 2 of my r's times pi, right? So I'm going to have circumference equals 24 times pi. Circumference is going to equal 24 times 3.14. So you'd have to, if you're doing this by hand, you'd have 314 times 24. So you'd have 4 times 4 is 16, carry the 1. 4 times 1 plus 1 is 5. 4 times 3 is 12. Placeholder 0. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. Add those products together. 6 and 0 is 6. 5 and 8 is 13. Carry the 1. 1 and 2 is 5. And 1 and 6 is 7. And then remember that you had 2 places to the right of the decimal on that 3.14. So you're going to need to move 2 places in on the left there on your product to get your final answer of 75.36 feet. Okay, 75.36 feet, or 75 and 36/100ths. So you'll have to practice using your decimal multiplication, finding circumference of a circle, and then you'll also find the area. You might be given to find the area of a circle that has the diameter of 12.5 feet. 12.5 meters, it says. This is example 10 on the bottom of page 379. So the first thing you need to do is find your radius. So remember that radius equals 2 r's together, right? 2 r's, 2 pi. So we're going to divide the diameter by 2. So $12.50, I think money sometimes when I see a 12.5, would be 6.25. That's our radius. So then we're going to have area equals pi times 6.25 to the second power. So you would do 6.25 times 6.25, right? That would be your first step. And this would take a little bit of time. I'm not going to waste video space on this. I know you know how to do this. And you'd ignore the decimals at first and just multiply 625 times 625. And because there's 4 places, you'd go 4 places to the left for your final product. Then you'd multiply that times 3.14, or 314. So it's quite a bit of math by hand. I would have a calculator ready to help do some of these so it speeds you up. Most likely on an exam we would allow you to use a calculator on a problem like this, but I do a couple of them by hand and then check your answer with the calculator. So that's the end of section 5.3 on multiplying decimals, and I will do the next video on 5.4 dividing decimals. So do some good thinking and studying in your homework. See you in the next video.